Welcome to the Walton Pi. Today we are going to be talking about indeterminate forms of limits and L'Hôpital's rule. So a useful thing that you might want to remember is that the little hat on vowels in French, when those words get translated to English, you can replace that letter with the hat with that letter with an S afterwards. So L'Hôpital's rule is sometimes seen as L'Hôpital's rule or Hospital's rule in different textbooks. So that might be something that you might see. So if we want to start by figuring out what indeterminate forms and L'Hôpital's rule have in common, first we need to define what an indeterminate form is. So if we are using the limit laws to evaluate a limit, and we end up with one of the following expressions, these are what are called indeterminate forms, since these forms can literally evaluate to any number or infinity. So if you end up with a plus or minus infinity over infinity, 0 over 0, infinity minus infinity, 0 to the 0, 0 times infinity, infinity to the 0, or 1 to the infinity, any of these could be any number. So if we have any of these, that means that we would need to figure out a different way to evaluate the limit. L'Hôpital's rule is one way that we can be able to do that. So if we can show that our limit can be written in the form in f of x over g of x, where that would go to infinity over infinity, or 0 over 0, then we can use L'Hôpital's rule to evaluate the limit. Notice that this is only the case for these two specific indeterminate forms. All of the others, so infinity minus infinity, 0 to the 0, any of those, L'Hôpital's rule does not work directly. L'Hôpital's rule only works if it's of the form infinity over infinity or 0 over 0. So if we have it being infinity over infinity or 0 over 0, then we can rewrite the limit as x goes to a of x over g of x that is equal to the limit as x goes to a of f prime of x over g prime of x. This is the really powerful thing. If you can write it as f of x over g of x, where that would go to infinity over infinity or 0 over 0, you can just take the derivative of the top and put it over the derivative of the bottom and then take the limit. This only works for limits. This is not something that's true in general, so if you have like f of x over g of x and you're trying to figure out what is that equal to, you can't take the derivative of the top over the derivative of the bottom. This is only if it's a limit and if it is in this very specific form. So for example, if we have the limit as x goes to infinity of 3x squared minus 5x plus 7 over e to the x minus 2, if we look at what's the limit of the top and the limit of the bottom, both of these go to positive infinity. So this is in the form that L'Hôpital's rule would work. So if we take the derivative of the top and the derivative of the bottom, the derivative of the top is 6x minus 5, and the derivative of the bottom is just e to the x. So now we can check, is this in a form that we can evaluate the number, or is it still in an indeterminate form? So 6x minus 5 over e to the x, this also goes to infinity over infinity. So what we can do is we can use L'Hôpital's rule again. So we can take the derivative of the top, which is going to be a 6, and the derivative of the bottom, e to the x, and then we can check, so this is going to be 6 over infinity, or in other words, 0. So that tells us that the limit as x goes to infinity of 3x squared minus 5x plus 7 over e to the x minus 2, that is equal to 0. Now, since L'Hôpital's rule can only be used in the cases infinity over infinity or 0 over 0, then any other indeterminate form, if we want to use L'Hôpital's rule, has to be rewritten to be in that form. So if our form is infinity minus infinity, then we should try and combine the two, hopefully into some fraction that will then match either infinity over infinity or 0 over 0. So if we were given the limit as x goes to 1 from the right of 7 over x minus 1 minus 17x over the natural log of x, what we can do is we can combine these two into a single fraction with a common denominator. So this becomes the limit as x goes to 1 from the right of 7 natural log of x minus 17x times x minus 1 all over x minus 1 times the natural log of x. Now if we look at this, this is going to be a 0 over 0 case. So we can use the derivative of the top and the derivative of the bottom and L'Hôpital's rule to help us solve this problem. So using L'Hôpital's rule, the derivative of the top is, let's see, so first we can rewrite the fraction. So we get 7 natural log x minus 17x squared plus 17x all over x minus 1 times the natural log of x, just to make it easier for us to be able to take the derivatives. So the derivative of the top is 7 over x minus 34x plus 17 divided by x minus 1 times 1 over x plus 1 times the natural log of x. Now if we were to look at this, this gives us 7 minus 34 plus 17 over a positive 0 plus a positive 0. Since we are approaching 1 from the right, x minus 1 will always be positive, 1 over x is always positive, and then the natural log of x, as x is coming from the right, is also always positive. So we are left with a negative number over essentially a positive 0, so smaller and smaller positive numbers. So that's a negative infinity. So this one turned out that we didn't need to use L'Hôpital's rule, but in other situations we might have had that situation. Actually no, we did use L'Hôpital's rule. We took the derivative, we just didn't have to do it a second time. For our third example, we might have the limit as x goes to infinity of e to the x minus x. So we might write this as the limit as x goes to infinity of e to the x minus 1 over x, and then we could get a common denominator. So we'd get the limit as x goes to infinity of e to the x over x minus 1 over x. If we then take the limit as x goes to infinity of the top and bottom, the bottom is going to be going to 0 is going to go to a positive 0, and the top is going to go to, using L'Hôpital's rule, the limit as x goes to infinity of e to the x over 1 minus 1. Now that goes to infinity minus 1 over 0, which is positive, which looks like it might be an indeterminate form, but it isn't actually one of those. Infinity over a positive 0 is just positive infinity. Now for our other three indeterminate forms, 0 to the 0, 1 to the infinity, or infinity to the 0, we can take the natural logarithm of this to be able to turn it into the indeterminate form 0 times infinity, which we can then try and rewrite to be infinity over infinity or 0 over 0. For example, if we are looking at the limit as x goes to 0 of x to the x, this is going to be a 0 to the 0, which is one of our indeterminate forms, so let's just say that that limit is equal to some number L. What we can then do is we can take the natural log of the limit as x goes to 0 of x to the x, which is the limit as x goes to 0 of the natural log of x to the x. We can then pull out exponents to the front, so this becomes the limit as x goes to 0 of x times the natural log of x, which is the natural log of L, since we were taking the natural log of both sides. If we can then figure out what the limit as x goes to 0 of x times the natural log of x is, we can then do e to that value to give us whatever L is. So the limit as x goes to 0 of x times the natural log of x, we can write this as the limit as x goes to 0 of the natural log of x over 1 over x. This is now in the form where we have infinity over infinity. So taking the derivative of the top and bottom, the derivative of the top is 1 over x, the derivative of the bottom is negative 1 over x squared, which again is going to be in the form infinity over infinity. However, if we were to rewrite this by multiplying the top and bottom by x squared, we would get the limit as x goes to 0 of negative x, which is now something we can evaluate. This is going to 0. So that means that the natural log of L is equal to 0, or in other words, the limit as x to the x equals L, which is e to the 0, which is 1. So that means the limit as x goes to 0 of x to the x is equal to 1. So, to recap, if we have a function over another function where they're going to be going to 0 over 0 or infinity over infinity, we can use L'Hôpital's rule to rewrite the limit as x goes to a of f of x over g of x as the limit as x goes to a of f prime of x over g prime of x if it is in the appropriate indeterminate form. I hope this video was helpful in understanding L'Hôpital's rule a little bit better. Please like and subscribe if you haven't already so that I can continue to make these videos. Have a great rest of your day, and good luck with the rest of your math.